Hello everyone. So let us have our practice solving in conservation of energy. So we have our first problem. A 70 Newton is applied to 10 kilogram block at rest for a displacement of 200 meters across a frictionless surface. Letter A, how much work is done? Letter B, what is the acceleration of the block in horizontal direction? Letter C, use kinematic equation to calculate the final velocity. Letter D, what is the final kinetic energy? And lastly, how much is the change in kinetic energy? So let us go first and determine what are the following given before we look for the unknown values. So the given in the problem are force, which is 70 newtons, mass, which is 10 kilograms, and the D, which is 200 meters. So to get the work done, let us have our equation work is equal to FD. By looking at the following given in the problem, all we have to do is to just simply plug in the values in the equation. So work is equal to 70 newtons times 200 meters. Just simply multiply the two values. We have 14,000 Newton meter or 14,000 joules. Next is we're going to solve for the acceleration of the block in horizontal direction. So in getting the acceleration of the block, we are going to use our equation F is equal to ma. Now let us go back here to the following values in the given. So we have the force, which is 70 newtons, equal to the value of mass, which is 10 kilograms, times the variable a for the acceleration. So in order for us to get the value of acceleration, we have to extract first or expand first the unit for newtons. So this is 70 kilogram meters per second squared equal to 10 kilograms times A. Then let us go divide both sides by 10 kilograms. So cancel this. We have the variable A, which is left on the right side, and cancel the unit kilograms on the left side. So 70 divided by 10, this is 7, and copy the unit meters per second squared. And this is now for the acceleration of the block. There it is. Now let us solve for letter C. For letter C, we are going to look for the final velocity using the kinematic equation. So, to get the final velocity using the kinematic equation, I will be using Vf squared is equal to Vi squared plus 2Ad. I will be using this equation because by looking at here on the following values, there's no time involved. So that's why that will be the equation that I'm going to use. And of course, as we all know, before the block move from one place to another, it is initially at rest. So therefore, the VI or the initial velocity is equal to 0. So we just simply cancel it in the equation. Now let us solve for the VF or the final velocity. So Vf squared is equal to 2 times the value of acceleration, which is already calculated for letter B. Just use the value. We have 7 meters per second squared times the D, which is 200 meters. So we have your Vf squared is equal to, we are going to multiply 2 by 7 by 200, and that is equal to 2,800 meters times meters. This is meter squared per second squared. So of course, since the variable BF is in square, we have to square root it. And of course, on the other side as well. Cancel the square root and the squared units. So square root of 2,800 is equal to 52.92 meters per second. This is now the final velocity of the block. For letter D, we are going to determine the final kinetic energy. Let us go here first to the delta KE. So delta KE can be also written as KE final minus KE initial. And as we all know, the equation for the KE or the kinetic energy is KE equal to 1/2 mv squared. So delta KE can be also written as 1/2 mvf squared minus 1/2 mvi squared. So let us go and determine the KE final or the final kinetic energy. So in getting the final kinetic energy, we are going to use this equation. So KE final is equal to 1/2 mvf squared. And then substitute the values. We have 1/2 times the mass, that is 10 kilograms, times the value of your Vf, which is 52.92 meters per second. Take note that in the letter C, the squared value of 52.92 meters per second is 2,800. So we are going to use this value. So we have 1/2 times the 10 kilograms times 2,800 meters squared per second squared. So we squared the value of the final velocity. And after that, we multiply the two values and divide it by 2. So that is equal to 14,000 kilograms meters squared per second squared, or equal to 14,000 joules. This is for the KE final. So for letter E, you have two ways to answer letter E. It's either you are going to calculate or you are going to give an explanation. Let us go first to the calculation. So we have here the change in kinetic energy. So delta KE is equal to KE final minus KE initial, or equal to 1/2 mvf squared minus 1/2 mvi squared. Okay, so we are going to consider this equation for the delta KE. So take note that before the block moves, it is from rest. So the inertial velocity will be equal to 0, then therefore cancel this one. So let us solve for the delta KE. The variables left will be on this side. So we have 1 half mvf squared. 1 half mvf squared. So in getting the change in kinetic energy, so just like what we did on letter D, we're just going to copy it here for letter E. Just plug in the values in the equation. This is now for the delta K. Now, how about if we are going to use the explanation? How are we going to write our final answer? Now, let us go to the relationship of the delta KE to the work. So, as we all know, work is equal to delta KE. So, if the value of work is equal to 14,000 joules, then therefore, we can say that delta KE is also equal to 14,000 joules. And this is now how you answer using the relationship of the work and the change in kinetic energy. And that's for our first problem. Thank you everybody for watching, and I hope that you learned something.